Good day. Welcome to our IGCSE Physics series. And we are looking at the first section of topics that you will find in your IGCSE curriculum. Here we will explain some concepts and try to give you a clearer understanding of what is in your textbook. Please feel free to pause and use the resources that we show in the slide series, and also note down anything that you think you will need in future. We hope you enjoy this series. Which force allows objects to fall freely? And this force will be gravity. So gravity is the pull that the Earth has on every single object on the surface, pulling it towards the Earth's surface. What is this acceleration called and how is it represented? It is called gravity, and it is represented by a g, a small letter g in your equations. When is this representation used? So when you are doing calculations for free fall objects or any falling objects, then you will replace your acceleration with a small letter g, because we know what the acceleration of gravity is on an object, or the pull of gravity is on an object. Why do we add positive or negative sign to indicate motion for vertically moving objects? So this is to indicate the direction that the object is moving. So remember, acceleration is a vector, which means that it requires us to show which direction it's moving. So a positive movement will be in whichever direction you define it, and a negative direction will be in the opposite to your positively indicated direction. So for example, if I say downwards is positive, then I will put a plus next to downwards, and if negative is upwards, then I will put a minus in front of any vertically moving object that is moving upwards. So let's describe this electronic timer. Firstly, we have an electromagnet, which is at the top, and a ball bearing. And then we have a switch, which we can switch on and off so that this electromagnet is either magnetized or not magnetized. When we take the magnetic pull away, then this ball bearing will fall towards the surface at the bottom, which is the trapdoor switch. So if we if we switch off the switch, then the ball bearing will fall into the trapdoor, and we will be able to measure how long it took the ball bearing to fall through the hinge at the bottom. Next, which equation is used to calculate? So which equation is used to calculate G, or a falling object? So as you can see, the equation that we will use to calculate this falling phenomenon will be the motion equation number 3. And the reason for this is that V initial will be 0 because it's a falling object. So it's falling from rest. And that's why we will only have here x, which is distance, or s, which is distance, and a half with g and t squared. So acceleration will change into g. So motion calculation number 3 will be used, and the a will be switched to a g. When is air resistance negligible? So when is air resistance negligible? It is negligible for very dense objects such as this ball bearing, because of the density and the heaviness or the mass of this object. Therefore, air resistance will not have any impact on the ball bearing falling. But if we had a feather that we let go at this level, then what will happen is the feather will swoop down to the hinge, and it will lay on top of the hinge. It will not have a straight down projectile. The same with a paper that you let go. So if you take a piece of paper and you let it fall, it looks like it goes straight down, but air resistance has an impact. So if you let a paper go with the flat side down, there is more air resistance than when you let it go down like that, with the sharp edge facing downward. This is also a working example which should help you to understand a bit more about the content that we have covered previously. You can pause and go through it at your own time. Thank you for joining us in today's session on IGCSE Physics. We hope that this topic has helped you to gain some insight into what you can expect in this curriculum for physics. Enjoy your day. Bye.